Hey, this is Mr. Resentis, and I'm going through the rules of significant figures. If you look on page 18 of your textbook, it explains it very, very well, but I thought that I could go through them briefly, and then in class we can practice it. So the rules for sig figs, and what I mean by that is significant figures. So when is a zero not significant? That is going to be probably the most difficult thing to determine. The regular digits 1 through 9 are always significant. 1 through 9 are always significant. Okay, so the only one that's really going to be a problem is this 0. So really just watch your zeros, and you'll determine the correct number of sig figs. Why do we care? Well, because the number of sig figs determines how accurate a calculation is. So when is a 0 not significant? Well, when it's a placeholder. Here's an example, 143. These zeros we would just refer to as a placeholder. It's just telling you that this is a really big number, so they're not significant. There's no indication there that these numbers were accurately measured. So in another case, these digits are not significant because they are they're just placeholders. Zeros are significant between non-zero digits. So numbers like here, you would count this as 5 significant figures. You would count this as 5 significant figures because they're between figures, between digits. So this indicates that in fact you did measure and come up with 10,043, and that was your exact measurement. Here we have a number that might cause some confusion, but because these numbers are to the right of these digits, these non-zero digits, these would be considered significant. This indicates to me that you did measure precisely each one of these digits, and in this case, that decimal indicates to me that you have in fact measured exactly 1,200. So both of these would have 4 sig figs. Both of these numbers would have 4 sig figs. So how many sig figs would you expect here? 2 sig figs. How many would you expect? How many sig figs would you expect in this case? No decimal, so we would just say this is 1 significant figure. You don't know, without a decimal, there's no reason to believe that this 0 was anything other than an estimation. So this would be to have 1 significant figure. This number would in fact have 2 significant figures. All right? And what about one last one? This number you would expect to have 3 significant figures, just as I explained here. 3 significant figures, right? Now in calculating, and then what I mean first is multiplication. and division, the measurement with the smallest or the least sig figs determines how many are in the solution. Right? So in calculating, and this is just for multiplication and division, the measurement with the least sig figs determines how many are in the solution. What does that look like? Well, if you were to calculate a number with lots of sig figs with a number with very, very few sig figs, the solution would just have 2 sig figs in it, right? So if we were to calculate this number on our calculator, just to out of curiosity, I'm wondering how many. Well, the number that they give on the calculators. Well, this would not be the number that you could put on your assignment or your exam, because this has more sig figs than the least number of sig figs in the equation. So we only have 2 sig figs here, so the answer would have to be, this would have to be our answer, because this has 2 sig figs, because this number has the same number of sig figs as the least accurate, which is 2. All right? And the same thing for division, the exact same thing for division. When adding and subtracting, the rules are slightly different. You count the sig figs to the right of the decimal. Alright, so when adding and subtracting, count the sig figs to the right of the decimal. And an example may be, in this case, the answer would be 34. You really can't include the this number 3 because you went through painstaking detail to find this digit. Well, it's wasted because this number is least accurate. And so that determines the number of sig figs, right?